Here are the solutions for the page 143 part 1 homework assignment. Question number 1 has an equation and we're asked, is this a conditional or an identity? If we simplify the left side by doing the distributive property, it becomes 2x minus 2. And we can see that that is identical to the right side. Because they're identical, this is an identity. Regardless of what value is substituted for x, the left side will always be equal to the right side. Question 7, is this an identity or a conditional? Let's simplify the right side by expanding that binomial. This becomes x squared minus 8x plus 16. Then we can combine like terms. This becomes x squared minus 8x plus 5. At this point, we can see that the left side is identical to the right side, so this is an identity. Regardless of what number is substituted for x, the left side will always be equal to the right side. Question 9, same question. Is this a conditional equation or an identity? Let's do some simplification on the left side. These can't be added together right now because they don't have the same denominator. So let's make this first term have the same denominator as this fractional term by multiplying the top and bottom by x plus 1. It will become 3 times x plus 1 all over the denominator x plus 1. The next term remains the same. Again, I'm doing work on the left side of the equation. I'm not doing anything yet with the right side. Now we can do the distributive property on this piece here. This becomes 3x plus 3 all over the denominator x plus 1. And there's still the plus 1 over x plus 1 next to it. Now that these have a common denominator, they can be added by adding the numerators. 3x plus 4 all over x plus 1. All of this work that I've done so far is to simplify the left side of this equation. The right-hand side is still 4x times x plus 1. It's not looking like the left side is identical to the right side. This denominator is x plus 1, and this denominator is x plus 1, so that means that the numerators must be equal to each other. 3x plus 4 has to be equal to the 4x. Subtract 3x from both sides, and we discover 4 is equal to x. The left side is only equal to the right side on the condition that x is 4. So this is a conditional equation. Number 11, we're given an equation and then asked to substitute different values of x to see if that solves the equation. In question A, we're asked to use 0 in place of x. So we would have 5 times 0 minus 3, and we're asked, will that equal to 3 times 0 plus 5? This makes negative 3, but this makes positive 5. The answer is no. X equals 0 is not a solution to this equation. Now we're asked to evaluate when x is negative 5. So 5 times negative 5 minus 3 will be the left side, and we're asking if it's equal to 3 times negative 5 plus 5. This makes negative 28. This is not negative 28. The answer is no. X equals negative 5 does not solve this equation. Now let's try x equals 4. 5 times 4 minus 3. Does that equal to 3 times 4 plus 5? This makes 20 minus 3, which is 17. And this is 12 plus 5, which is 17. This is yes. Now let's try when x is 10. This is 50 minus 3, which is 47. And this is 35. The answer is no. From number 15 onward, we're asked to solve the equation using the algebra skills that we've learned in Algebra 1 and Algebra 2 class. This is a very straightforward equation. All we need to do is subtract 10 from both sides. This is an S. I'm just communicating that I'm subtracting 10. The answer is x equals 5. That can be checked by substituting in place of the x and going 5 plus 10 just to ensure that it makes 15. For problem number 19, the first step I'm going to do is to subtract 3x from both sides. 8x subtract 3x is 5x. And on the right side, now there's only the 10 there. The next step will be to add 5 to both sides. This makes 5x is equal to 15. Finally, divide by 5, getting x is equal to 3. To check the answer, you can substitute a 3 here and a 3 here, work out this expression, work out this expression to make sure they're really equal to each other. Number 23. This time I'm going to work inside of the grouping symbols first and distribute that minus sign. So my very first step is the distributive property, dp. I'm just communicating to you what I'm doing. So 6, then the bracket, the x, and I'm going to distribute the negative sign. So the negative distributed to 2x is negative 2x. The negative distributed to the positive 3 is a minus 3. And then I'm copying the rest of the equation down. The next step, inside the grouping symbols, there are some like terms. They both have an x. So I'm going to combine like terms. 6, bracket, 1x subtract 2x is negative 1x. Everything else stays the same. In the next step, back to the distributive property, because we want to distribute the 6 to both terms in the brackets. 6 times negative x is negative 6x, and 6 times negative 3 is negative 18. In the next step, let's remove the negative 5x from the right side of the equation so that it comes over here with this x term. I'm going to add 5x to both sides. Negative 6x add 5x is negative x. Everything else stays the same. Next step, add 18 to both sides. Negative x is equal to 26. And the final step, multiply both sides by negative 1. That's how you fix the negative here. And the result is x equals negative 26. There were a lot of steps. At any point, it would have been easy to mess up. So we can check the answer by substituting every place where there's an x, and then making sure that the left side really does equal to the right side. Problem 27. There's different ways that this can be done, but I'm going to approach it by removing those fractions instead of distributing the fractions. To do it, I'm going to multiply by the lowest common denominator, which is going to be a 4. I'm going to multiply all of the terms by 4. So 4 times 3 halves makes 6. 4 times the negative 1/4 makes minus 1. And 4 times 0 makes 0. By multiplying all of the terms by 4, I've removed the fractions from the problem and made it easier looking. At this point, let's do the distributive property. 6z plus 30, and then minus 1z minus 24, and that's equal to 0. Now combine like terms. 6z minus 1z is 5z. 30 minus 24 is positive 6, and that's equal to 0. Now subtract 6 from both sides. 5z is equal to negative 6. Finally, divide by 5 on both sides. Z is equal to negative 6/5. Again, there were a lot of steps, and there were even fractions in there, which is easy to mess up. So we can check this by substituting in the answer we got for z. Use a calculator when you do that to help you with the fractions, and check to make sure it really does turn out to be 0. Next, number 31. This is a very similar problem. I noticed there's fractions. So I'm going to multiply all the terms by the lowest common denominator, which is a 12. When you multiply this one by 12, think about what 12 over 3 reduces to. That reduces to a 4. So it would become 400 minus 16u. What happens when you multiply this by 12? Think about what 12 over 4 reduces to. It reduces to a 3. So this would become 15u plus 18. Finally, remember how we were multiplying by 12? 6 times 12 is 72. Okay, in the next step, I'm going to subtract the 15u from both sides. So we have 400 minus 31u equals, and then I'm also going to combine the 18 plus the 72 and save a little writing. That makes 90. Okay, in the next step, I'm going to subtract the 400 from both sides. This is negative 31u is equal to negative 310. Final step, divide by the negative 31 coefficient to get the final answer of 10. Next, number 35. I see fractional expressions again. So I'm going to multiply every term by that denominator of x. I want to times that one by x. I want to times that by x. I want to times that by x. And times that by x. Here's what's going to happen. 10x minus this x and this x will cancel away, leaving 13. Right in this position, it becomes 4x. And then on this part right here, those x's will cancel away, leaving positive 5. Now we can subtract 4x from both sides, making 6x minus 13 is equal to 5. We can add 13 to both sides, getting 6x is equal to 18, and then divide by the coefficient of 6, getting x equals 3. To check our work, we can substitute a 3 into that original expression. Is 10 minus 13 thirds really equal to 4 plus 5 thirds? Because of the fractions, it might be a good idea to type that in the calculator to see if it checks. 10 minus 13 thirds is 5 2/3. 4 plus 5 thirds is also 5 2/3. This answer checks. Number 39, another equation that contains fractions. Let's multiply all of the terms by the lowest common denominator, which is the x plus 4. We're going to multiply this one by x plus 4, this one by x plus 4, this one by x plus 4, and even this one by x plus 4. Here's what's going to happen. Those cancel out, leaving the x. Those cancel out, leaving the 4. This will become 2x plus 8, and on the right side, it's still a 0. Next, let's combine like terms. X plus 2x is 3x, and 4 plus 8 is 12. Then subtract 12 from both sides, getting 3x equals negative 12, and divide by 3, getting x equals negative 4. Let's check our answer by substitution. And look what happens if you substitute a negative 4 right there. Negative 4 plus 4 makes the denominator equal to 0. Negative 4 is a restricted value. It's not in the domain for this equation. Because negative 4 is not allowed to be used, and there are no other possible answers, this equation has no solution. Number 43, another equation in which there are the fractional expressions. Let's use our same technique where we multiply all of the terms by the lowest common denominator. We're going to multiply this first term by x times x minus 5. the lowest common denominator has both factors in it. It has the x factor from here and also an x minus 5 factor from over here. This number 2 also needs to get multiplied by x times x minus 5. And even the 0 needs to be multiplied by x times x minus 5. Now let's write down what we get. This x and this x cross out, so we're only left with 1 times x minus 5. Now let's work in this middle position. This x minus 5 and this x minus 5 cross out, we're left with 2x. Equals, and over on this side, 0 times anything is still 0. Now we can combine like terms. X plus 2x is 3x. Then add 5, getting 3x equals 5. And then divide by 3, getting x equals 5/3. Let's check and make sure that plugging in 5/3 actually works and that 5/3 is not a restricted value. It's okay to put 5/3 here because that does not make a 0 in the denominator. And it's okay to plug in 5/3 here because 5/3 minus 5 is also not a 0 in the denominator. We can take our check beyond that by actually working out the left side to guarantee that we really get a 0. 1 over 5/3 plus 2 over 5/3 minus 5. We're wondering, does that make 0? Because of the fractions, it would be a good idea to use the calculator. 1 over 5/3 means to do the reciprocal of 5/3, which is 3/5. Working this out on the calculator, I get negative 3/5. And when you subtract these, it really does equal to 0. So this answer checks out. Next, number 47. We've finally gotten away from those fractional expressions, but this time there's squaring involved. So let's expand this portion here. This becomes x squared plus 4x plus 4. Everything else I'm going to copy down. Except right here, why don't we do the distributive property right now? 4x plus 4. Okay, in the next step, look at how the x squared and the minus x squared cancel away. So we have 4x plus 4 on the left side and 4x plus 4 on the right side. Do you see that they're identical? This is an identity, meaning no matter what number you plug in for x, this side is always going to be equal to this side. So the answer is all real numbers. Any number can be plugged in for x. Finally, number 51. How about doing some distributive property? So we have 4 minus 2x plus 4b. And that's equal to ax plus 3. In the next step, I'm going to subtract the ax term to make it move from the right side over to the left side. So this is 4 minus 2x plus 4b minus ax. And that's equal to 3. We're trying to collect the term with the x on the left side of the equation, so any other terms we want to move to the right side. Let's subtract the 4. So we have negative 2x plus 4b minus ax equals, and then 3 subtract 4 is negative 1. Let's subtract the 4b term. We have negative 2x minus ax equals negative 1 minus 4b. Notice how these are like terms. They both have an x in them. Let's combine like terms. We have negative 2 minus a times x. And that's equal to negative 1 minus 4b. Next, let's divide by the negative 2 minus a, by that coefficient in front of the x to get the x alone. So we have negative 1 minus 4b, all divided by negative 2 minus a. This finally has the letter x alone, but it seems kind of weird to have negative, 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 negative. It seems like we could do better than that. So let's rewrite the right side by factoring out a negative 1. it becomes negative 1 plus 4b. And on the bottom, we could even factor out a negative 1, so it becomes negative 2 plus a. Now, what will happen with this negative over this negative? Do you see what will happen? They cancel away. So the answer is x equals 1 plus 4b all over 2 plus a. We can write that right here.